23rd, 2011, and we're going to deal with lesson 2.1. So you guys were to copy down these definitions and the diagram from the key concepts. We're going to move on from there. We're going to be dealing with midpoint of a line today. So, there it is. Midpoint of a line. Get this a little bigger. If you guys look at example 1 on page 60. Okay? So example 1 on page 60. Not sure why that does that. They've given us 2 points on a graph. Oh, this graph doesn't quite reach that. We'll go up by 2s on this graph. So this graph's going to go 4, 8, 12, 16, 20. It's going up by 2s, okay? All right, so we've numbered our grid. The points they've given us is point A is at 3 and 5. So on the x-axis, we're going over to 3. So that's halfway here. And 5, that'll be halfway up here. So our point A is right there. 3, 5. And they've also given us point B, which is 11 and 14. Do that in blue. So 11 is about halfway here. 11 and, what did I say it was? 14? 14, which is right along here. So we connect the two. Our point B, 11 and 14. First of all, those are 2 points on a single line. So we'll draw our line in black here. We have our line. In the question, they want us to figure out the rise and the run of these shapes. When you go to look at rise and run, what you're going to soon discover is that it will create a triangle. So, first one, if I come across here, and that line, and that line, we can tell the distance of the lines are going to actually equal the rise and the run. So we went up from 5 all the way to 14. That gives us 9. So the side of this triangle is 9 units. That's our rise. That's how far it's gone up. And our run, we went from 3 over to 11, so we moved 8 units. 8 units. So we now have 2 sides of a triangle. We can discover A, first of all, the length of that other line using Pythagorean theorem. We have a right angle triangle. But right now what I want to do is I want to find the midpoint of this line. So you guys were to copy down this equation, and it said x1 plus x2 over 2, y1 plus y2 over 2. When you plug the numbers in from our 2 points along the line, it will give you the exact midpoint of this equation. Okay? So we're going to number our A will be our 1s. Okay? So this will be our first coordinates, and B will be our 2s. These will be our second coordinates. So when we plug them in, x1 is 3, and y1 is 5. We'll complete the rest here so you understand what I'm plugging in. Plus x2 is 11, and y2 is 14. So we took those points from point A and point B. We carry out the equation. 3 plus 11 is 14 over 2. 5 plus 14 is 19 over 2. Okay? We have a fraction. We're actually going to have to divide this fraction. I want an actual number, whether it be a decimal or not. 14 divided by 2 is 7. 19 divided by 2 is 9.5. So what that now means is the midpoint of our original black line, the one I first drew, x is 7, y is 9.5. So if I go across to 7, which is roughly about here, and I go up to 9.5 is a little harder to get. About here. Oh, where did my 7 go? 9.5 is probably right here-ish. I now have the midpoint of my line. If I was trying to just find that midpoint by eye, it'd be very difficult. I need to plug in my numbers into this equation we have. x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we end up with our midpoint, we'll call it M. Point M is 7 and 9.5. That's the midpoint of that line we discovered. The rise and the run, we already noticed, was rise is 9, 8 is the run. So our slope was 9 over 8. If we needed to figure that out, we created our triangle to solve that. Our slope was our 9 over 8, which is our rise over our run. Our midpoint was 7 and 9.5. Okay, I want you guys to try number 1. Page 66. Try number 1 right now, A, B, C, and D. Okay, these are the answers to number 1. 1A, 4 and 6, 1B, 1 and 3, 1C, 2 and 2, 1D, negative 0.5 and negative 2. You can just take the numbers that are on the graph, plug them right into the equation. This is one way to solve for the median of a line. There is another way to solve for the median of a line. I'm going to do it right now. I'll put this entire page up for a second. Come on. Okay? Move pages. Using another grid, okay? We're going to do another example. I'm going to make it up quickly and show you another way to solve this. We'll just use the numbers. This is a scale of 1, okay, guys? So it's going to go 1, 2. Pretty easy scale, okay? 2, 4, 8, 10. We're going to have our point A at 2 and 6, 8. It's a little off there, but okay. So I need to get the median of this line once again. I need to find the median of this line. One way the book has shown you guys how to do this is you take x1, which will be our first point. You take x1, you add it to the run divided by 2. That will give you your first point. And your second point, I believe they give you it as y2. What did they say it as again? Y2. Y1. Y1 subtracted by rise divided by 2. Oh, sorry, we're still at y1, not y2. This should be a plus. Okay. Oh my gosh, look at this thing. Okay. So what this is showing you is if you take the very first point, that means we'll be taking this point here because we're adding. This is going to be our 1. We have to make sure we define the point properly. If I were to start up at the top right, which I'm going to put in blue right now, if I was to plug those points in and add away, I will not end up at the median. Okay? You have to look at which way this triangle is shaped. We have a positive slope, so we're able to use this specific formula for it. The idea of this formula because you're going to have to change it as it goes along, is first of all, they take the first coordinate. So we'll take that first coordinate, x1, and x1 is going to be at 2. So x1 is 2, and y1 is 2. Very nice. Our run is the first thing we're going to figure out. We'll do it in red. Our run goes from here. So it goes from 2 to 6. It's a little high up the drawing, but it goes from 2 to 6. So what that means is the entire run, we're going to find the distance of it, okay? From 2 to 6 is 4. So I'm taking the number 4 divided by 2. What that means is I know the distance of this line here is 4 units long. I'm dividing it by 2. So I'm taking half the distance of that line, and then I'm moving from x1 that same distance. I'll show it as an actual visual. Our y2, same idea. Do this one in blue. Our first point, we go up. Our rise goes from 2 to 8, so our distance is 6. This one was 4. If our distance is 6, we take that number, divide it by 2, and it's going to give us our new median. So 2 and 4 divided by 2 is 2, so our next point is going to be 4, and 2 plus 3, 5. So this tells us our median is at 4, 5, which is right here. 4, 5. The reason this works is because we're taking the distance of these triangle, the shape we've made that's a triangle, and we're dividing them in half. In other words, we're going halfway, which is the median. The median means we're going halfway. If the triangle is the other way, we'll actually have to move backwards, okay? If our triangle was to the left, we'd subtract by the run divided by 2. And if it was an upside down triangle, we were going down, we'd take y1, subtract rise over 2. You have to look at your triangle. If I had taken these points and then moved 2 spots over, and how many spots up was it? 3? 3 spots up. I would have got a median way out here, okay? You have to make sure you start at the right point. It has to make sense to what the formula says. This one's a little harder to work with. You can use this one if it's easy for you. The one I showed you just before that will always work if you put it into that formula. x1 plus x2 divided by 2 and y1 plus y2 divided by 2 will always work. So if you're not sure how to work on this formula, you can always use the other one.